Okay, in this session, let us discuss some of the softwares used in computer-aided design. Basically, you think that CAD means computer-aided drafting, right? But it is not only the drafting; it is also design. It is also the design, drafting. That means the computer-aided design includes the drafting and as well as the analysis. So if you include both, so that is called as CAD software. Okay, so basically there are different types of computer aided design softwares. As I said just now, design includes modeling and the analysis. So in the modeling stage, we are not going to analyze the component. Analysis means with respect to your requirements, whether the design, whether your objective is going to meet the requirement or not. Assume that your objective is to design a coupling. So based on your required calculations, so you need to analyze that. So while transmitting the required power, so that coupling is going to sustain the required power or not, whether it is going to fail or not. So that is what the analysis part. So that analysis part will be carried out using the analysis softwares. So the analysis softwares available in the market is Abacus, then ANSYS. So these two are the familiar softwares commercially available outside for the analysis purpose. Then as I said just now, this CAD also includes the modeling. The first step is modeling. In the first session, we have seen that from the conceptual design, we are going to create the geometric model. So after creating the geometric model, that will be analyzed. Okay. So then the next part is to process planning, then code generation, then that code will be integrated to the CNC machine. So this is what we are discussed in the last session, our overview of CAD CAM session. So in this CAD, computer aided design, finally I can tell you that computer aided design includes modeling and as well as analysis. So analysis part includes design part, drafting part includes the modeling. Then the analysis part includes the analysis software, or the analysis part is going to analyze the component, whether it is satisfying your requirement under actual conditions or not. So that analysis will be performed using the analysis softwares like the Abacus or ANSYS. So these two are familiar softwares. So suppose if you want to work in the core and software side, these two softwares you have to learn. Of course, you also have the softwares, you also have the opportunities in modeling side also. So more opportunities in the modeling side like Unigraphics, CATIA, ProE, SolidEdge and SolidWorks. These are the modeling softwares, geometric modeling softwares commercially available outside. So these softwares are also having the opportunities outside. You can also get the placements in the modeling side and as well as the analysis side. But analysis side is upper hand than the modeling side. I am aware, as per my knowledge. So you will get more package in analysis side than the modeling side. So this is different discussion. So as of now, you think that so CAD includes the modeling softwares, then the analysis softwares. So in this session, we will see what are the different modeling softwares and what are the different analysis softwares. What are the features of all those softwares and what are the disadvantages. So briefly, we will look into those softwares available in the market. So now let me move further to see. So in the last session, we are all discussed the hardware components used in CAD system, CAD workstation, input devices, graphic terminal we have discussed, hard copy devices. Then finally, we are also discussed the storage devices. Now in this session, let us see the types of CAD models. So what are the different CAD models? As you're fully aware, you have the 2D CAD model, 3D CAD model, even in the 3D CAD model also. So we have different types. I will tell you what are those different types in this session. Then after discussing the different types of CAD models, then I move forward to discuss the different CAD softwares. Then finally, I will also discuss the features of the CAD softwares. Okay. So then computer communication networks, I don't think I'm going to cover in this session because the time is very limited. So I will discuss computer communication networks in the next session. So in this session, we will discuss the types of CAD softwares, types of CAD models, then features of the CAD softwares. Now, when it comes to the types of CAD models, so you have 2D CAD model, I mean two-dimensional CAD model in which you are going to draw the components. So only by representing the 2 dimensions. So by the name you can see that the drawing will be 2-dimensional. Only 2 dimensions will be given. Third dimension you don't get. So that is called 2D CAD. I think you have drawn your CAD lab. You have drawn in the CAD lab 2-dimensional drawings you have seen. Of course, some extent in the final stages you were also drawn the 3-dimensional drawings. So that is the 2D CAD drawing. AutoCAD is the software used for a famous and familiar software used for the 2D drafting. Of course, some extent AutoCAD can also be used to generate the 3D softwares. Okay, sorry, 3D components. But whenever you want to create the complex components like I mean advanced surfaces like B-spline surfaces, toroidal surfaces, or non-uniform surfaces. So whenever you want to generate the components which are having the advanced surfaces, as I said just now, is very difficult using the 2D, I mean AutoCAD software. That we will see in the next slide. Then we will also see what is the wireframe model. In the case of wireframe model, so I mean this wireframe model is also going to represent the 3 dimensions. And similarly, we have other type of 3D CAD model, that is 3D surface model. So we will see what is wireframe model, what is surface model, then we will see what is solid model in the coming slides. Now let us see what is 2D CAD model. As I said just now, 2D CAD model means so the drawing which is represented with only two-dimensionally is called the 2D CAD model. Okay, so the drawing which is drawn using with the 2 dimensions is called the 2D CAD model. Okay, so you can see one figure here, so in which you can find the two dimensions only, one along the x-axis, one along the y-axis, as you can see here. So this, when all the material objects are 3-dimensional, of course, what is the importance of these two? You may get a doubt that, so why do we need 2D drawing? Because you have the drawings, so like you have the components like the sheet metal component. The sheet metal components doesn't have the third dimension, so that in that case we require the 2-dimensional drawings. Okay, so I mean such as paper cuts and machine parts made of sheet metal. So in that case, these 2-dimensional drawings are applied in the case of sheet metal drawings. That is the one of the application of the 2-dimensional drawings. Okay, so this is regarding the 2-dimensional models. In the case of 2-dimensional CAD models, we have only 2 dimensions. Okay, so now let me move further to see what is the wireframe model. So this type of modeling describes an object using only boundary edges. So boundary edges, I mean a model is represented using only the edges. Edge can be an arc, edge can be a line, right? So it is only represented using the edges. So edges can be lines, edges can be arcs. So that is called, that type of model, CAD model, that type of 3D model is called the 3D wireframe model. That means it looks like a mesh model. It is also called as a mesh model. In which case, in this case, you have only wireframe model. So by the name, you can say that wireframe or mesh model, the model which is going to be represented using only the edges and arcs, is called the wireframe model. It is just like a skeleton. Just you imagine the skeleton of the body, human body. So you will get all the, you can see only the bones. Like that, if you want to represent any of the model using the edges, so that type of model is called the wireframe model. Then when it comes to the surface model, the model which describes an object using boundary surfaces. In the first case, wireframe model, we are described the model using the edges. So that model is called the 3D model. Whenever you want to describe the model which is going to describe using the surfaces. Okay, described using the surfaces is called the surface model. Okay, as you can see here, so in this figure you can see the same component, but it is section component, it is full component, full model. In this case, so you will find only the lines, right? You will find only the edges. The model is represented using only the edges. So that model is wireframe model. Now you see here. So if it is a surface model, as you can see here, so this model is going to be described using only the surfaces. That means it is just like a sheet metal tin. Okay. Of course, so of course it is a solid one. Of course, in this case, it is just like a tin, which is not having any material inside it. As of now, you think a model is described using the surfaces. Whenever a model is described using the surfaces is called the surface model. As you can see here in this figure, it is just like a tin, right? It is described using only the surfaces. Surfaces we are representing. Of course, this is also a three-dimensional figure. Three-dimensional surface model, three-dimensional wireframe model. Both these two models are the three-dimensional models, but one this wireframe model is represented using only the wires or the edges. Sorry, edges. The surface model is described only using the surfaces. Okay, so these two, of course, this surface model looks like realistic model, but it doesn't have any material in it. You cannot assign any properties. In the case of the wireframe model and as well as in the case of surface model, you cannot assign any material, right? So these two drawings doesn't have any density at all. So if you assign the properties, so properties like the density, you cannot assign because it is not filled with the material. It is not having any material. So you cannot assign the properties. So that is called the surface model. The model which is described using the edges is called the wireframe model. The model described using the surfaces is called the surface model. So both these two models are the 3D models, but you cannot assign the properties in both the cases. Okay, but this surface model looks like the realistic model. Okay, but you cannot assign the properties. Okay, so physical properties, as you can see, the density is the physical property, right? You cannot assign. Then let me move further. So the actual model, the solid model or 3D CAD model, solid model. Okay, now you see here. So solid model, the object which is described, okay, which is described and assigned with all the properties like the weight, volume, the additional properties, as you can see here. So the model which is assigned with the properties like the weight, volume, density is called the solid model. So this is actually the realistic model that you come across outside. So whenever you create a solid model using any of the commercially available software, so you can assign all these properties: weight, volume, and density. Okay, weight, volume, and density. This is the realistic model. So in this case, we are going to assign all the properties like the weight, volume, and density. So like the physical object. So physical object means that you can see with your eyes. Okay, it looks like the realistic object, and as well as it is also assigned with the properties. So that is called the solid model. So in any of the commercially available software, you are going to create the solid model. Of course, you can convert this model. So those softwares are having flexibility to convert this solid model into wireframe model and as well as the surface model. You have flexibility. So the moment you create this solid model using any of the commercially available software, you can convert that model into wireframe model and as well as the surface model. You have the flexibility. Okay, but basically you are going to create the solid model. Okay, so that is assigned with the physical properties like the weight, volume and density. Okay, this is called the solid model. So then let me move further to see. So types of CAD software. So those are the different CAD models. So as of now, we have discussed the different types of models. Okay. So one is 2D model, wireframe model, right? Surface model, then solid model. These are the different types of models, and that is the difference between the models. Now let us see the different types of solid models. Okay. Sorry, CAD softwares. So actually these CAD softwares are going to use the computers. Obvious, a software definitely use the a computer. So these softwares are used to create, modify, analyze, and optimize the design. So now, as of now, this CAD includes design, I mean modeling and the analysis. As of now, you think that this CAD, so this CAD indicates the modeling and the analysis part. So that's why he's trying to explain the computers are used to aid, create, modify, analyze, optimize the design. Is called the CAD, overall CAD. CAD includes the modeling and analysis part. So in this case, computers are assisted. Computers are used, are aided to create, modify, analyze, optimize the design. Okay, so this is called CAD. So CAD software is also termed as graphic software because you can see everything as on the screen. That's why we are calling it as a graphic software, because where everything we are working with the images. Suppose you are creating a model, so that model is a graphic, right? So whenever you are analyzing, again you are taking the geometric model, then you are analyzing. Analysis means you take some model and you apply load, you apply torque. So then you can assess where is the maximum stress. So what is the maximum value of stress, whether it is within the limits or not. So that those values can be analyzed. Even you can animate using the softwares. So these analysis softwares, using the analysis softwares, you can analyze. So when you apply, so for example you take the cantilever beam and you apply load at the free end. So when you apply the load, and what will be the deflection, how much, what is the value of the deflection at the free end. So everything, even you can see how the beam is going to deflect. So that will be analyzed. That part is called the analysis part. So so basically CAD software is the collection of number of programs. Even you take the AutoCAD backend, there are number of programs. So maybe C programs, maybe Java programs, maybe C++ programs, even to draw one line from. So whenever you issue line command, you are fully aware that it will ask for the start point. So the moment you select for the start point, it will ask for the next point. But how the system is prompting you to start point and end point, isn't it? So there must be backend programs. So there are some programs are going to run. Okay, so to prompt us, even to create graphic. So it is creating line while selecting the end point, start point and end point you are selecting. In between start point and end point, it is creating a line, isn't it? So this back end, I mean, even you can see only line in the front end. Okay, so you are interacting with the graphic user interface, GUI, right? So the whatever you are interacting is the GUI, graphical user interface. Okay, you are interacting with one interface, so that interface is the graphical user interface. But backend number of programs will run. Even you take the operating system like Windows, even Windows also you are saving, you are save as, right? You are issuing the print command. So just the moment you click on the print command, you will get one dialog box, isn't it? So that dialog box is also created using the number of programs. Okay, so back in any of the software or any of the application, so back end number of programs will run. Okay, so that is what he's trying to explain. Okay, so computer CAD software is also termed as a graphic software because we are using the graphical user interface, we are dealing with the images, right? So that's why we are calling it as a graphic software. Then it is also defined as the collection of number of programs. So any of the software, you take any application, you take WhatsApp, or you take any Facebook, you take Twitter, you take any of the application, you take PUBG game. So just you imagine thousands of lines of code. So thousands of lines of programs will run backend to run the program, to show something on the screen. So this is what the number of programs are collected at one place to run that application. As of now, application means it is a CAD software. You think in that way. So CAD software is nothing but, so it is a graphic software, and it is also defined as the collection of number of programs. Okay, written, make it convenient for the user to operate from computer graphics system. Okay, so CAD software is used basically, what is the need of the CAD software? It is used to increase the productivity, right? Then it is to improve the quality of the design quality increases, and improves the communication, documentation, right? So it is going to store the documentation, right? And it is also going to maintain the database means it is going to store all the files at one place. Whenever you want, you can retrieve the files. So that is called the database is the place where all the files or the data will be stored. That's all as of now. You think in that way. So all the manufacturing data, all the drawing data, all the graphic data, all the design data, all the modeling data will be stored at one location. So that place is called the database. Okay, so it improves the quality, right? It maintains the database, it communicates through the documentation, so which is stored somewhere else, right? So increases the product. These are the uses of the CAD software. Okay, so now, so I left only 1 minute, so I will discuss the types of CAD softwares tomorrow. Okay, so okay, thank you one and all. I will stop here now.